Hi, welcome back to 1.3 maximum or minimum of a quadratic function. In this example, we will be solving a maximum or minimum problem. Rachel and Ken are knitting scarves to sell at the craft show. The Wolf Reed scarf costs $6. They were planning to sell the scarves for $40 each, the same as last year when they sold 40 scarves. So that's about a $4 profit per each scarf. However, they know if they raise the price, they will be able to make more profit, even if they end up selling fewer scarves. They have been told that for every 50-cent increase in price, they can expect to sell 4 fewer scarves. What selling price will maximize their profit, and what will the profit be? Okay, so in order to do this question, uh, we need to think about the number of 50-cent increases in price. Okay, so for every 50-cent increase, they sell 4 fewer scarves. Okay, so what that means is if they increase the price too much, they're not going to sell very many scarves and there won't be much profit. Okay, however, if they don't increase the price at all, then there's not going to be that much change in profit either. So there's a certain number of increases in price that will actually give them the most profit, and we want to determine what that is. So we're actually trying to find the maximum profit in this question. You can see how this ties into the maximum of a quadratic, and we'll see that very soon. So let's begin by introducing a variable. Let, um, let's introduce a variable x, and we'll let it represent the number, okay, of 50-cent price changes. Okay, so if x is 1, that would mean 1 50-cent increase in the price. Okay, if x was 2, then we would have 2 50-cent price increases, and that would be a dollar increase. So you kind of get the idea from that. So the profit, okay, is going to equal the profit per scarf. So this is how much money they're going to make off of just one scarf times the number of scarves sold. Okay. So in order to maximize this profit, we need to come up with an expression that depends on x, the number of 50-cent price changes. So the profit per scarf. So normally the profit is $4, right? Because it says they can make one for 6 and sell it for 10. So normally the profit is $4. However, as they increase the price, they're gonna make more profit. So it depends on the number, it depends on X, the number of price changes. So the profit is going to be 4 plus 0.5 times X. Okay, so we can see from this that if X was 1, that would mean we would have 1 50-cent price change. So if we put in a 1 here, the new profit would be $4.50. If we did 2 changes, 2 50-cent price changes, half times 2 is 1, and the new profit would be $5. So we can see this expression represents the profit per scarf, and it depends on X, the number of 50-cent price changes. Okay, and then this is going to be multiplied by the number of scarves sold. So in the past, we can see here they've sold 40 scarves. However, depending on the number of 50-cent increases in price, they can sell 4 fewer scarves. So normally they sell 40, but for every X, they're going to sell 4 less. So we're going to write minus 4X. Okay, we can see this works really good. So if there's going to be one 50-cent price change. That means if x is 1, if we set x equal to 1 and plug it in, we're going to have 450 times 36. Okay, that would be the profit. If x is 2, we're going to have to plug 2 in, and then we would get a new profit and a new number of cars sold. Okay, now there's a certain value for x. There's a certain value that's going to give us the biggest output for this, and we want to figure out what that is. Okay, now notice this is a quadratic, and what we want to do is we want to expand it. We want to put it in standard form. So we're going to do FOIL. So 4 times 40 is 160. Okay, and then 4 times negative 4x minus 16x. A half x times 40, well, a half of 40 is 20, so we'll have 20x. And then a half times 4 is going to be negative 2, and the x times x, negative 2x squared. Okay, in standard form, we need to have our term with the highest exponent stated first. So we're going to write minus 2x squared. We're going to collect like terms with these middle terms here. Negative 16 plus 20 gives us 4x. And then our last term plus the 160. Now we can really see this is a quadratic, and our negative leading coefficient means it's going to open down. Okay, and if it opens down, that means we have a maximum value. Okay, so we're looking for that max value. So we know we can solve this 2 ways now. Okay, we're going to find the maximum by finding the vertex using our completing the square method. So I'll write here method 1, completing the square. And we'll do that to find the vertex. Okay, that's our first method. After we do this, we'll see how partial factoring works too. So completing the square, I'm going to write down my function. So I know I called it a profit before, but I like to give it a more formal variable. I'm going to call it P of X, P for profit. So we can see the profit depends on X, the number of price changes. So P of X equals negative 2x squared plus 4x plus 160. Let's go ahead and complete the square. First thing we need to do is remove the coefficient from the first 2 terms. Okay, so that means we're dividing negative 2 out from both terms. So 4x divided by negative 2 will be minus 2x. Close the bracket, plus 160. Okay, in this line, I'm going to add and subtract my b over 2 squared. Okay, b over 2 squared in this case is going to be, here's the b value. Okay, so we'll have negative 2 over 2 squared. Well, that's real easy. It's just negative 1 squared, which is just 1. So I have to add a 1 and subtract a 1 inside my bracket, and then we have plus 160. Okay, now we created a nice perfect square trinomial, and we'll need to institute another set of brackets when we write this. So we'll do minus 2. I'm going to write my square bracket in, and now I'm going to factor this. So we would have x minus 1 squared. Okay, and then we have our negative 1, which I'll write in. Okay, close up the square bracket, and then we have plus 160. Really important to keep the square bracket in here because we can't just take this negative 1 out without multiplying it by the negative 2 first. So that's what we're going to do in this next line. We'll actually use a round bracket here. So let's just draw this like this. Okay, we're going to distribute those in. Okay, I got plus 2 because negative 2 times negative 1 gives me positive 2. And my next line, we have x minus 1 squared plus 162. Therefore, the vertex is 1, comma 162. All right, so this profit function, if I were to graph it, it would look something like this. So there is profit and then x, the number of price changes, and our vertex is at 1, all the way at 162. So that's my vertex up here. And then this opens downwards. So it's probably going to look something like this. Okay, and we can clearly see the maximum value. So to answer our question, what selling price will maximize their profit and what will the profit be? So we can tell that from this maximum point that x needs to be 1. Okay, remember that x is the number of 50-cent price changes. So according to the graph, we should only have one 50-cent price change. So let's put our answer in here off to the side. Okay. So max profit occurs when x equals 1. Okay. This means the price is going to equal, remember, the scars were sold for $10 each, and we're doing one 50-cent increase, so we're going to have 10 plus a half, because there's just one 50-cent increase. So 10.50. So that selling price will maximize profit. What will the max profit be? Well, we can see from this equation that we could plug in our value of x and get the total profit in here by calculating it. Okay, we can also plug it into here as well and do just the product. So all we have to do is plug in our 1 for x. So we'll say here, and also, like, we can do that in the equation, but we can also see it from the graph, right? When we graph our profit versus, remember this is profit versus number of price changes. So we actually can see the profit is already 162. So we don't really need to plug this value of 1 into the equation, like over here and here. You can tell though, if we do, we actually get 162. So, all right, let's just put that in a response, and we can say the maximum profit is $162. Okay, and that is our first real life application question solved by maximizing a quadratic. Okay, I do want to show the second approach now. Okay, that was method 1, completing the square. Let's go ahead and look at the partial factoring process. So I'm just going to go ahead and shrink this. That way we can hang on to it for later when we go to check our answer. And I'll do this one in red. So this is going to be method 2. Try that again. Okay, and we're going to solve by partial factoring. All right, so if you remember, we need to rewrite our equation, so this one here, but we're going to drop that last term. Okay, we don't need that last term in it, so let's going to look like negative 2x squared plus 4x. Okay, and then next thing we do is we need to factor this. So we will take out our greatest common factor, which is negative 2x. When I divide negative 2x out of the first term, all I'm left with is just x. And then the second term, all I'm left with is negative 2. Okay, because 4x divided by negative 2x is just negative 2. Okay, so now this is in a nice factored form. I want to grab the zeros. Okay, the zeros for this, they're going to be whatever makes this bracket 0. So if x is equal to 0, that's the first one. Let's change colors here. X equal to 0, that's the first one. And then the second one, x would need to equal 2. Okay, those are the values that make this equation 0. Okay, that's why they're the x-intercepts. They're the values of x that make y 0. So if you plug 0 into here, this becomes 0, and the whole thing is 0. And we've just found an x-intercept. Okay, so what are those handy for? Well, when we're looking at our graph, the x-intercepts can help us determine the axis of symmetry. Okay, and we want the axis of symmetry because our vertex, the x value of this is actually going to be this, whatever the axis of symmetry is. And then we're going to have something for the y value. So that's really why we do this, is because it's to help determine the vertex. So axis of symmetry, this is the average of the two intercepts. It's the middle value between them. So we're just going to add them, 0 plus 2 over 2. And we get 1. So now I know that this vertex, I no longer have to keep that a mystery. I can put in 1. Okay, because there we have our intercept 0 and 2, and it's quite obvious 1 would be right in the middle. All right, now we're looking for the y value. Well, I don't want to take this and plug it in up here, because remember, this is our modified equation. We dropped the plus 160. Okay, I'm trying to get the vertex for this profit function. So I need to take this 1 and I know how to plug it in to x up here. So all we need to do now is determine p of 1. Okay, I always put the axis of symmetry into there so that I can find the y value. Okay, so p of 1 is going to be negative 2 times 1x squared plus 4 times 1 plus 160. So you can already see, like, I already got the same value for my vertex that we did down here, right? We already got 1, so we can already see how this works. Okay, now we're going to have negative 2 times 1 squared. 1 squared is actually just 1, so negative 2 times 1 is negative 2. 4 times 1 is just 4, so we got plus 4. And then we have plus 160. And I get 162. So you can clearly see from this method, we get the same value for profit. And we also got the same value for the number of price increases. Okay, and that is it for this example. We'll see you in the next video.